Hi, my name is Abby Lewis, and today I'm going to be talking about a systematic literature review of near-term ecological forecasting that I led in collaboration with a number of co-authors from Virginia Tech. So I want to start off with a really excellent quote from a paper published in 1932. In this paper, William Hodgson is predicting herring population demographics 1 year into the future. So this is a near-term ecological forecast. And he concludes by saying, "We hope that before long, these prognostications will be issued with the same confidence as those that are broadcast daily by the Meteorological Office." 90 years later, I think many of us would still consider this to be an aspirational goal, but near-term ecological forecasting has clearly developed substantially over time. To document that progress and identify future directions for the field, we performed this literature review. Our study had three goals. First, we aimed to characterize near-term ecological forecasting fairly broadly. At what rate are forecasts being published over time, and where around the globe are those located? Second, we aimed to analyze the adoption of best practices in ecological forecasting, drawing from a number of lists of best practices that have been published over the past several years. And third, once we had compiled this data set, this was a really amazing resource to be able to compare forecast skill across papers and analyze the relative predictability of ecological variables. I'll get into all of these more throughout my talk. For our systematic literature review, we started very broad, since ecological can be tough to define or might not show up in papers as with near term. And then we did manual screening. Our initial search turned up 3,183 papers, and we read the abstracts of all of those papers, and then the full text for some papers in order to identify those that are predicting the future, which is our definition of a forecast, those that are organismal or biogeochemical, which is our definition of ecological, and they needed to predict less than 10 years into the future. Using those criteria, we ended up with 178 papers that we considered to include near-term ecological forecasts. When you analyze those 178 papers, what we found very quickly is that near-term ecological forecasting is a rapidly growing field. So starting from that Hodgson 1932 paper, there were very low forecast publication up until just the past couple decades, where we've seen dramatic increases in the number of near-term ecological forecasts that are published each year. These forecasts are published for sites on all 7 continents. You can see the one for Antarctica here, but not evenly divided across the globe. As with many meta-analyses and global research studies, South America and Africa and a good portion of Asia are very poorly represented among near-term ecological forecasts published to date. As the rate of forecast publication has increased over time, a number of best practices have been proposed. Specifically, we drew from 4 papers that have been published in the past few years, and we analyzed those practices that are mentioned by at least 2 of these 4 papers. So doing that, we came to a list of 9 practices that are divided between 3 tiers. A couple that are considered requirements for forecasts, a couple that are particularly beneficial for decision support, and a few that are particularly beneficial for research purposes. Today, for the sake of time, I'm only going to talk about 4 of these practices that I think are particularly useful or interesting to folks within the Ecological Forecasting Initiative. Great, so here I'm showing those 4 practices. The x-axis is time from 1980 through the present, and the y-axis is the probability that a forecast publication from a given year will demonstrate that best practice as calculated using logistic regression. Include uncertainty is the most prevalent practice, but it's still fairly low. Under 50% of forecasts include uncertainty. In the year 2020, logistic regression is predicting that approximately 25% of papers mention a specific end user, which I think is actually kind of remarkable given that many forecasts are not developed for decision support purposes. So there's a statistically insignificant upward trend in the number of papers that are identifying an end user. But there are statistically significant upward trends in papers that make data available and automate their forecasting workflows. So near-term ecological forecasting literature is becoming increasingly open and automated, despite most of these practices having fairly low rates of adoption to date. Finally, once we had compiled this amazing data set, we really wanted to see if we could say anything about the relative predictability of ecological variables. So here I'm showing aquatic chlorophyll A forecast, just as one example. These data are drawn from 8 papers, each of which are represented by a different color here. On the y-axis, we have forecast performance in R², and R² is an imperfect metric of forecast performance, but this was the most commonly reported metric in our study. And it's useful because you can compare across different variables very easily using a metric like R². On the x-axis, we have forecast horizon, ranging from predicting 1 day into the future to predicting 7 days into the future. And what you see is that on a 1-day forecast horizon, we're able to make very good predictions of chlorophyll, but that forecast performance decreases sharply over a 1-week timescale. And you can compare that rate of decrease between chlorophyll, phytoplankton, so this is individual phytoplankton taxa, and 2 terrestrial variables, pollen and evapotranspiration. Like chlorophyll, phytoplankton also starts with very high forecast performance, and that decreases quickly. You can see those results summarized in the figure on the right, the blue and black lines here. Pollen and evapotranspiration start much lower and decrease at a slower rate. And so those are the green lines summarized here, and you can see that there's a difference in both the intercept and slope of forecast performance over increasing forecast horizons between chlorophyll and phytoplankton, which are these very similar aquatic variables, and pollen evapotranspiration, which are different terrestrial variables. So this is a very preliminary analysis, but I think it's really cool to be able to start to compare the predictability of ecological variables across sites and ecosystems. So in summary, there are 3 key findings from this paper. First, near-term ecological forecasting is widespread and rapidly growing. A number of best practices have been proposed, and while the current rates of adoption of those best practices are low, they are increasing for many practices over time. And third, forecast comparison. So comparing across all of these different papers, we can learn about the relative predictability of ecological variables. These results have been published in Ecological Applications at this point, and I really encourage everyone to dive into that paper and read more about our methods and results, or I would be happy to answer questions also. And I just want to send a huge thanks to all of the co-authors that made this work possible, as well as funding sources. I look forward to interacting with you all at the FE conference this week. Thank you.